Alright guys, so in this video I want to talk about dimension analysis. Now dimension analysis, you may have seen this before, but really it's not like a concept, but it's just more of a way of doing things. And more specifically, we're talking about math. So dimension analysis is just a way for us to convert from one unit to another. And I know oftentimes we do unit conversions here. I mean, we do it all the time. So let's just say we're going from quarters to dimes. We're going from dollar bills, like $1 bill to $50 bills, or inches to feet, whatever the case is. So sometimes we do these calculations all the time. But as I said, dimension analysis is just kind of like an easy way to kind of do this on paper and to convert from one unit to the next, especially with units that we're not too familiar with. Okay, so like for example, let's just talk about this conversion. Let's say we're wanting to know how many, so if we have 15 feet, what is that in inches? Okay, that's what we're trying to figure out. Okay. Now, to do this, we will need what we call an equivalence statement. Now, equivalence statement is basically, it just tells you exactly how one unit, the relationship between one unit to the next. All right, what's that absolute relationship? The relationship that we know, the relationship that we understand. So, like, for example, we know that for every 1 foot equals 12 inches. All right, so that's the equivalence statement. Or something I like to call EQ statement. All right, so that's the equivalent statement. So we know that for every 1 foot, you have 12 inches. All right, and so now what we're trying to figure out is, okay, well, if this is the relationship, how many inches are in 15 feet? Now, what you could do with the equivalent statement, you could come up with two conversion factors, okay? With almost all equivalent statements, you can make two conversion factors. Now, how do you make these conversion factors? So basically, what you simply do, you just turn the equivalent statement to fractions, where one side is the numerator and the other side becomes the denominator, and vice versa. So like, for example, here's our equivalent statement, right? So we'll turn it to fractions. So the one could look like 1 foot over 12 inches, or you flip it, where you have 12 inches over 1 foot. All right. Now, as I said, these will serve as our conversions to answer the main problem that we have up here. So this is our main problem. And so we're going to use either this conversion or this conversion to answer the question. Okay. Now, so now we need to figure out which conversion to use. Okay. So the conversion to use is really, honestly, it's just kind of based off of the units of the problem. Okay, and what do I mean by that? Well, if you pay attention, well, I'm kind of writing everywhere, I'm sorry. If you pay attention, you're going from feet to inches, all right? And so essentially what you're trying to do, you're trying to cancel out the unit feet and add in the unit inches, okay? And so we got to figure out which conversion factor we need to use to actually help us do that. And so how I typically do this, I'll write it out. So here's my problem, 15 feet, all right? And we're trying to convert this to inches. So what you will do, so we will multiply by a particular conversion factor. So it's either that we choose this conversion or this conversion. It's one or the other. Okay. Now, how do you know which one you use? It's all about unit cancellation. So you got to be able to cancel out the units in order the unit that you don't need to the unit that you want. So for example, I don't want the unit feet anymore. So how do I get rid of this unit feet? Well, if we're using this, so this is our conversion. Well, we know to able to cancel out this feet, which sits as a numerator, really. So it's kind of look like this, essentially. All right, then we will need the unit feet to be at the bottom here. Okay. And then we're going to inches. So we need the inches to be on top. And the only conversion between these two that actually flip the bill is really this one here and not this one. All right, so we'll use this conversion. And while we'll use this conversion, because if you notice, we can now cancel out feet because they're on the opposite sides of the dividing line. All right, so one is the numerator, the other one's the denominator. All right, so we can cancel it out, and then we'll be left with inches. So when you're actually sitting there and you do the math itself, then basically what you're going to have is, I'm going to kind of highlight this, you're going to have 15 times 12 inches, so now we have inches, divided by 1. And then when you plug this into the calculator, you'll see that your answer is 180 inches. All right. And so we just got to get used to make sure that you always use units, right? Numbers cannot be left out naked. All right. Because, like, for example, if I come to you and it's like, hey, I have 6. And you're going to look at me as like, 6 what? All right. The number, yes, is important, but what comes after the number, that unit, is what's really, really important. So if I tell you, hey, I have 6 cats, then you understand exactly what the 6 is referring to, all right? It's referring to the unit, which is cats. And then, we could have a conversation from there. But a number, just writing a number doesn't really make sense. You have to make sure you include the unit, so that way it gives context to the number, okay? So let's go with another example. So let's just say we're trying to convert. All right, so we're converting 34.6 hours, if I could spell hours, to minutes. Okay, so we're going from hours to minutes. Now, the first thing, as I said, the first thing you want to do is get your EQ statement, your equivalent statement. All right, how are these units related to one another? How are our hours related to minutes? What standard do we know? Well, we know that for you have 60 minutes is equal to 1 hour. That's our EQ statement. Okay. Now the second thing you want to do is write your 2 conversion factors, or 2 possible conversion factors, I would say. All right. So what are the 2 possible conversion factors that we have? So as I said before, what you simply will do, you'll just make one the numerator and the other the denominator, and then you flip-flop for the second conversion factor. All right. And so in this case, you could have either 60 minutes over 1 hour, or 1 hour over 60 minutes. Okay, so these are our 2 conversion factors. Which one do we use? It depends on the question. So we have to go back and look at this question here, all right? And it's going to help us to determine which of these conversion factors do we use. So let's go ahead and write out this problem so that we can solve it. And then, so now we know. So we'll start off with, we got 34.6 hours, right? Hours, and we're trying to convert that to, once again, to minutes. Okay, so 34.6 hours times which conversion factor we use. Well, we need the conversion factor that's going to cross out this hour, which sits as a numerator. So which of these 2 fits that bill? Is this one, because your hour here is a denominator, and so it will cancel out this hour here, and then you're left with exactly what you're looking for. You're looking for minutes, and that's what we wanted. Okay, so when you're doing this mathematical expression here, so in your calculator, what you will simply write is 34.6 times 60, and if you really want to, you could divide that by 1, and your answer will simply be 2,076 minutes. Okay, so basically that's how we go through, and that's the process of dimensional analysis. And it's really helpful, especially when we're dealing with units that we're not really familiar with, especially a lot of the units that you will see in chemistry.